Okay, so welcome everyone to Guided Study Group Week 9 of Statistic 100. So this week we're going to be working on the materials, last piece of materials before midterm 2. And also I would just want to remind you the review for midterm 2 is going to be this Sunday, July 15 at 9 p.m. And so today is lesson 9, is the diversity of samples. So this is kind of like, the further discussion of what we've learned so far in the course. So last week we learned about the law of large numbers, which say average and proportion are likely to be more stable when you have more trials, while the sum of the counts are likely to be more variable. It does not, and then the law of large numbers does not happen by compensation for a bad run of luck, since independent trials have no memory. So the trials are independent, and just kind of like the sample doesn't have the memory function. So just because of some events happen to occur so frequently, it doesn't mean that there's going to be more chances for all the possibilities to happen. Again, look at the example 8.6, section 8.3 in the online notes. Then you're going to be able to understand more about this. Continue this discussion. This week, we are saying because there is a law of large numbers, but there's no law of small numbers. So just basically saying, if you have a few incidents or events that happen, you cannot use that to generalize the big pictures or generalize it as the principles of how things work. We also have a discussion of the gambler's fallacy, where you have the trials are independent and have no memory. So just because you throw a dice and you get 5 times in a row, it doesn't mean that there are going to be more chances of the rest, because it doesn't have any memory and each trials are the same for a fair dice. If you have anecdotes, just a few of them cannot be generalized because the sample is small, and usually those anecdotes are coming from the people that are not randomly chosen from the population. Usually you seek answer from those people, and they kind of like have a similar background where they tends to have the similar outcome. And finally, coincidence. Coincidence happen does not guarantee the fact that they're more likely or less chance of any kind of outcome. So in case of coincidence, say you bought a car and you saw the same car on the street, it doesn't mean that that car now become more popular. You just happen to pay more attention to it when you buy a new car. We also have the new thing is the normal approximation. So it is saying the sampling distribution of average or proportions from a large number of independent trials approximately follows the normal curve. So say if you have the sampling distribution of a bunch of average, then most likely if you do that using stat key or mini tab express, then you're going to see the distribution going follow the normal curve. And the sampling distribution is basically you just use stat key to pick out maybe like a sample of 5 or 10, and then you find the average of each of them, and then you graph those average. So say if you have a sample of 100 trials, you just pick like maybe a sample of 10 trials, and you do that 20 times or 2,000 times. Then each time you're going to take an average, then you put them in the distribution. Then you're going to see the fact that this average of all the trials that you take is going to follow the normal curve, which is a bell shape like this. The expectation of a sample proportion or average is the corresponding population value. And again, when you do say, if you take that 200, you're going to learn this method called bootstrapping. So which is basically taking the samples. As I say, you have a big sample, you pick out like 5, 10 trials, and you do it like 2,000 times. And then you try to graph the average and proportion. So your average and proportion is 95% likely that it's going to be the population value. So it's going to be the population mean or the population proportions. But then it's only 95%. And I mean, if you want to learn more about it, feel free to like go through the online note of statistic 200. Then you're going to be able to learn more about it. Right now, we just need to know that from this sampling distribution of average and proportion, the expectation of a sample of the sample proportion or average is the corresponding population value. We also have two formulas to calculate what is the standard deviation of a sample mean, which is going to be the population standard deviation divided by square root of n, with n be the sample size. So say if you take sampling distribution of size 10, then n is going to be 10. And then you have standard deviation of a sample proportion is going to be square root of p multiply 1 minus p divided by n, with p be the population proportion. And so this one, when you're looking for standard deviation of a sample proportion, usually the variable that we're talking about is categorical variable. That's why you only have a proportion. But in case you have like quantitative variables, it's like numbers, in that case you're gonna have standard deviation of a sample mean, which is here. Then we talk about how do we actually use normal approximation and what are the conditions that we need to satisfy to use it. So first of all, the trials that you take in the sample must be independent. So either it's stated clearly or there's some hint in the questions giving you that that the trials are independent. You need to interpret what the question is asking. So usually the question is either going to give you the mean or the proportions or something about a sample. And so you need to understand if it's a categorical variable or quantitative variable so that you know what formula you're going to use to find the standard deviation. Then for sample proportion, to use the normal approximation, n multiply 1 minus p and np have to be at least 5, so bigger than or equal to 5. For sample mean, say you have quantitative variable. So if you have slightly skewed distribution and no outliers, n has to be bigger than 15. For skewer distribution, you're gonna have n has to be bigger and bigger until it reach around 40 or 50. Basically, these conditions is just to make sure the fact that the normal approximation is used when the original population is closer to normal curve. So if usually, as we already learned, I think in the previous lessons, I don't know which lessons for exactly, but we talk about how population distribution is closer to a normal curve, and to do that, we usually need bigger samples, and so that's why we need n to be bigger than a certain number to make sure that our distribution is closer to a normal curve. Now let's do practice questions and problems. And again, if you have any questions during the sessions, email me, or if you're listening to me online, feel free to mute me to work on it alone. Question 1. A retail carpet business has primarily residential customers together with a few commercial customers that make large purchases. Overall, the business sells an average of 100 square yards of carpet with a median sales of 40 square yards. So average of this and standard median sale of 40. A standard deviation of 90. So you have median 40. Average 100. Standard deviation 90. Now you have average bigger than median. So from what we learned in the previous week, we can say that this is a skew distribution. And so because the difference between the median and average is so big, then we say that it's strongly skewed. And so I think it's skewed to the right. And so this is going to be the median, and the mean is going to be like this, 100. Now, which of the following would be the closest to a normal distribution? The histogram of the next 100 individual cells. If you write them down like this and you look at the next individual cells, you don't know if it's going to be on this part or on this part. So there's nothing guaranteed that it's going to be, normal distribution. So A is not likely, and the same thing applies for B. You have no idea about the histogram of the last 100 individual cells. One more thing to notice is that in B, for the last 100 individual cells, the trials or the events each cell might not be independent from one another, because if you think about it, you only have that much of goods left. So during the last cells, and so the last cell and the next to last cells are going to be dependent on one another. Whatever you sell in the next to last is going to determine how much you have left for the last cell. That's why B cannot be a normal distribution for two reasons. First of all, there's nothing guaranteed that's going to be a normal distribution. It doesn't give us a hint on, like, is it an average, is it proportion, is it sampling distribution, or anything. It just say the histogram of the last 100 individual cells, and the trials are not independent of one another. Then we have C, the sampling distribution of the yardage sold in the next cell. Now, if you talk about just in the next cell, n is equal to 1. So you're going to take the sample of each of the cell. So you take the sample of 1 from the next cell, and then you do sampling distribution of that. Well, I mean, if you do it like 5,000 times, it might be likely that you have a normal curve. But if you have a bigger sample each time, so if you take like n equal 100 and you do that 5,000 times, it's more likely that you're going to have a normal curve, which is what we talked about. Which one we talk about normal approximation over here. You need a large number of independent trials. And so in this case, if you look at D, the sampling distribution of the average of the yardage sold for the next 100 cells. So n is equal 100, and also you take the average of that. So based on the principles of the normal approximation, D is going to be the answer, because first of all, each time you take a sample of 100, then you take the average of them. So by that case, I mean, if you guys want more information on it or understand it better, search for bootstrapping method in statistic 200. You're gonna see why, for clearer reasoning, you're gonna see why this one follows the normal distribution. Then the extra question is asking the standard deviation of the average amount of carpet sold to the next 100 customers would be. So you have the next 100 customers. So n is equal to 100. And here they given you a standard deviation of 90 square yards. So you're going to use the first formula using for quantitative variable, where you have the standard deviation of the sampling distribution is going to be the standard deviation 90 divided by square root of 100, which is going to give us 90 over 10, which is going to be 9 square yards. Again, if you have any questions, please let me know. I understand that this section can be a little bit confusing to understand and figure things out. So I would expect you guys to send questions, but if I don't receive any questions, I'll assume that you guys understand this. And so I'll skip it and go ahead. Question 2, we would like to use the normal distribution to calculate chances about how a sample average might turn out. In which of the following situation would the normal approximation work the worst? So remember, the question here is the worst. So basically it's asking which of the following situation would be the least possible to use a normal approximation. So we're going to check the conditions for the normal approximation. So first of all, you look at sample A and 1 and 2. So 1 is following normal curve. So any sampling distribution from number 1 is going to be more likely to follow the normal curve, because the original population itself is already normal, which is like the final conclusion of my in this part. So anything from 1 is more likely to work better than in 2. So in 2, it is strongly skewed to the right. And so you need a larger and larger sampling to make sure to use the normal approximation. And so the bigger the sample, the better it works. So D is better than B, so B is going to be the answer. Again, if you want to work on this one alone, please come back and maybe like mute me and work on it on your own. Third questions, again, mute me if you want. The weight of boulders removed from a quarry average 120 pounds. So average is 120 pounds. And standard deviation is 200 pounds. We are about to randomly select n of these boulders and look at the average weight. What is the difference between the shape of a sampling distribution for this average when n equal to 1 compared with when n equal to 100? Now don't look at the answer because it's going to confuse you because it's a lot of work, but just think about it. When you take the sampling distribution of a bigger sample, then from what we learned so far, it say that it's going to be more likely to follow the normal curve. Therefore, our conclusion is that for n equal to 100, the graph would look more like a normal curve than n equal to 1. Now let's look at the answer. When n equal to 1, the sampling distribution would be skewed right, while n equal to 100 would look like a normal curve. Now that one sounds right to me. You don't know if it's going to be skewed right or skewed left, but then definitely for n equal to 1, it's going to be skewed. Another one is B is not right because it's the completely opposite of A. Then C, the shape of them would look the same. Well, that one is not right either because the sampling size actually determine if your sampling distribution is going to look more like a normal curve. So A is the correct one. Actual questions, what are the standard deviation and mean for each sample size? So first of all, when n equal to 1, you have mean is the same, which is 120 pounds. But then your standard deviation is going to be 200 pounds divided by square root of 1, which is going to be 200. Now, if you have n equal to 100, again, the mean is the same because it doesn't depend on the sample size. But then your standard deviation is going to be much smaller, divided by 100, which is going to give me 20 pounds. Which kind of give us the sense that the standard deviation is basically another way to interpret standard error. So if you have smaller standard deviation, if you want to make a predictions about your value, standard deviation is going to be smaller with the bigger samples, which makes sense because now your value and your prediction is going to be more accurate because when you take a bigger samples, you capture a bigger pictures of the populations than taking just a smaller sample. Now, the last questions, no, not the last one yet. The question 4, the letter D, E, I, R, W are printed on cards and put into a hat. Next, the cards are drawn out randomly one at a time. Which is the most likely sequence that they came out? Well, I mean, since each of the card only have one of them, and so each of the combination can only happen once. Therefore, whatever order that is printed out, there's only going to be one change in the entire possibility that's going to happen. We're going to say both orders are equally likely. Unless you have things like they're asking for the words like D, E, E, D, and then T or something. And then you have 3 E's or like 3D. Then the word may be like deed or, maybe red or something, then it's going to be more likely to happen because the number of these quantities and the possibility of it happening is higher. Question 5, again, mute me if you want to work on it on your own. The chance that a certain type of thumbtack lanes point up when you toss it in the air is 80%. This makes the standard deviation of the proportion of times it lanes point up out of 100 toss equals to. Now, here you're given a proportion, and so in this case, and it's only when you have a thumbtack and you throw it and it either pointing up or down, it doesn't have a number, therefore it's a categorical variable as well. So 2 reasons that give you the hints that you have to use the second formula to find the standard deviation. And so P here is 80, and so you have SD is going to be 0.8 multiplied 0.2 divided by 100 toss, which is 100. it's going to give 0.16 divided by 100, which is going to give me square root of 0.0016, and it's going to give me 0.04, which is going to be C is the answer for this. Again, the math is not that hard. Basically, you just have to identify which formula you have to use. And so with that in mind, if you don't have any questions, or if you want to email me questions later, feel free to do that. Just some final notes. The next review is this Sunday at 9 p.m. and it's gonna be the midterm 2 exam review. Please do your own review first if you can, or try to have a look back at the online notes and the assignments that you did in the week since midterm 1, and work out the practice exam problems if you can, so that you can join me in that sessions and ask questions. So with that in mind, thank you for listening to me, and I'll see you guys this Sunday. Bye.